Hello, this is Mr. Flatness, and today's lesson will be focusing on factoring polynomials. This is lesson 8.5. Our goals for this video and lesson will be to use the distributive property to factor polynomials and then solve equations in the form of ax squared plus bx is equal to 0. Some vocab to put in your notebooks. Factoring is basically the process of finding the greatest common factor of every term that you would see in a polynomial. So it goes way back to your 5th and 6th grade years when you were learning about the factors of whole numbers. Well, now we're going to look at common factors within a polynomial. And then we're going to use a word called undistribute, and basically what we're doing is we're going to be doing the distributive property in reverse. So go ahead, take a few moments, copy down the terms here, and then we'll move forward. So let's review the distributive property again. If I want to take 4 times the quantity x plus 3, we learned that we're going to take 4 times x to get 4x. And then we're going to see that we have a plus sign. And then we're going to take 4 times 3, which is going to give us 12. So our answer, in a more simplistic way, after distributing, I would get the monomial 4x plus 12. So now that we have that information from the previous slide about remembering how to use the distributive property, we came up with this equation, or we came up with this answer, 4x plus 12. Well, so what we can do here then, if I want to factor things out and put it back to the way it originally was in the previous slide, I can write the long way these two particular terms. So 4x I can rewrite as 2 times 2 times x. And when I factor these out, I want to make sure that I'm dealing with all prime numbers. So if you can remember back to your 5th or 6th grade year when you did prime factorization, and then plus here, and then I'm going to factor out 12 to be 2 times 2 times 3. So now what I want to do is take a look at what do they have in common. Well, over here, the 4x has 2 times 2, and 12 has 2 times 2. So 2 times 2 is 4, so basically I can factor out the number 4 out of there. And if you remember in the previous slide, 4 was outside the parentheses. Now what's left over that did not get combined, or that was not in common? X and 3. So inside the parentheses I can go x plus 3. And so what I've done is taken the binomial 4x plus 12 and turned it back into a distributive property example, 4 times the quantity x plus 3. So let's try another one together. This time I have a trinomial, 4x cubed plus 6x squared plus 8x. So what I can do is, again, write out each term and expand it. So 4x, again, would be 2 times 2 times x times x times x. So that would take care of the 4x cubed. The 6x squared would be 2 times 3 times x. I got the plus sign in there. And then the 8x would be 2 times 2 times 2 times x. So let's look at what they all have in common. Okay, so from what I can tell, each one has a 2 in it. 2 here, a 2 here, and a 2 here. So I can factor out a 2. And also I see that they have one x in common. X, x, and x. So I can factor out that x out of here too. So 2x is what's going to be outside the parentheses. Now I'm going to just plug back in what's left over. So looking at what's left over, I see that we have a 2 and two x's. So that's going to be 2x squared plus, over here I got a 3 and an x that's left over. So that's going to be 3x plus, and then what's left over here is a 4. So if you take a look at my finalized answer, I have 2x is what I factored out of the equation, and then we have 2x squared plus 3x plus 4. The last thing that I can do is to check my answer. Is 2x times 2x squared 4x cubed? Yes, it is. Is 2x times 3x 6x squared? Yes, it is. Is 2x times 4 8x? Yes, it is. So in this case, I can see that factoring out the 2x was the right thing to do. I'm also going to look inside the parentheses to make sure there's no other common factors of all three, which there are none. So another example for you to again go through step by step, put this in your notes, maybe replay the video once or twice to kind of get the hang of what I'm doing, so that we can move forward with this skill tomorrow when we meet. The last thing we're going to talk about in this video is called the zero product property. And the zero product property states that if the product of two factors is 0, so in other words, two numbers, two factors, when I multiply them, if their answer is 0, then at least one of the factors has to be 0 no matter what. So algebraically, we would just say that a and b are real numbers. So if a times b is equal to 0, then either a has to be 0, b has to be 0, or both a and b can be equal to 0. Okay? And a final note that we want to create here or think about is a solution or a root of an equation is any value that makes the equation true. Okay? So again, that's your x-intercepts on a graph. So let's take this understanding and knowledge and apply it to the next skill. So I want to solve this particular equation by using the zero product property. So we're saying that the binomial x minus 2 times the binomial 4x minus 1 has to equal 0. So back with my properties, if I know that two factors here equal 0, then I know at least one of these two factors has to equal 0, or both can. So in that case, I can solve this equation by simply saying, well, x minus 2 could be equal to 0, or 4x minus 1 could be equal to 0. And so now I'm just going to use the SIC process to solve for x. So I'll, in this case, add 2 to both sides and find out that x could equal 2. Which, if you make sense, if I plug 2 in for x up here, 2 minus 2 is 0. Well, 0 times anything is 0. So that checks in that example. Or, then we can take a look at adding 1 to both sides on this particular equation and getting 4x is equal to 1. I can divide both sides by 4, which then x is equal to the fraction 1/4. And again, if I plugged in 1/4 for x up here, 4 times 1/4 is 1, and 1 minus 1 would be 0. So what do I have? I have two answers. X can be equal to 2, or x can be equal to 1/4. Because they're x equals, that means they're going to be on the x-axis, which means they are the solutions to this particular equation, or what we would call the roots. Roots and solutions mean the same thing. And again, where are they going to find these answers? On the x-axis. Very similar to when we were solving quadratic equations. Again, this should be something that you have in your notes as examples in practice. So, for tonight, we would like you to take a look at solving these two particular examples. In the first one, we'd like you to factor the polynomial, and in the second one, we want you to use the zero product property to solve the equation to find the roots or solutions. Have a great night, and we'll see you tomorrow in class.